Okay, so this is the third talk in the session, and this is by Umesh Patil. And the talk is titled Prominence-lending Cues as Weighted Retrieval Cues, a Computational Cognitive Model of Processing German Pronouns. Thank you.
Thank you. Okay, so moving from two really interesting data talks to a modeling talk, and moving from English to German. So in the next 20 minutes, I'm trying to convince you that why modeling is also fun, along with experimental work, and why German is doing experiments and doing modeling with German is also cool and why it's fun. All right. So German pronouns. So German has personal pronouns like in English, sie, er, es, he, she, it. And interestingly, it also has demonstrative pronouns, which are used more productively and more frequently in German than in English, and a bit differently as well. So German has demonstrative pronouns which are equivalent to or comparable to the personal pronouns as die, der, and das, so 3 different genders. So now if you consider a sentence such as the firefighter wants the boy, the firefighter wants to rescue the boy, but he is too nervous. So instead of he, in German you could use the personal pronoun er, or you could use the demonstrative pronoun der. Okay. If you use the personal pronoun er, one could say that it has a slight preference towards the subject antecedent, which is the firefighter. Whereas if you use the demonstrative pronoun there is a strong preference towards the object antecedent. Okay. So in general, we could say that in German, personal pronouns prefer antecedents that are prominent, and demonstrative pronouns from the there, the das paradigm prefer antecedents which are not highest in the prominent scale. So now prominence can be defined or can be manipulated in terms of subjecthood, agenthood, order of mention of the antecedents, topicality, and perspectival center, and so on. Okay, so across all of these factors are going to influence the prominence of different referents. So now if you consider the sentence that I just mentioned, so in this sentence, what we have is the personal pronoun, as I said, prefers the subject. And if we look at its features in terms of prominence, it's the subject, it's also the agent of the verb that captures the action, and it's also first mention. So if you consider these 3 prominence-lending cues, all these 3 cues are with the first referent or with the firefighter, right? And on the other hand, if we look at the prominence cue with the DP, the boy, it's the object, it's the grammatical object, it's the patient, it has the patient theta role, and it's also the last mention. Okay. So we have this separation of prominent cues. So most prominent cues are, so highest prominent cues are with the subject or the first referent, and low prominent cues are with the object. So in this case, it's much clearer in terms of distribution of the prominence-lending cues. Okay, so first referent has all the prominent cues, second referent has low prominent cues. So this is a active accusative verb. So verb like rescue, it's an active accusative verb because it assigns a accusative case to the object. And in this case, we get this clear separation. But that doesn't have to be the case if we change the word order now. So if we consider the non-canonical word order, where we just swap the subject and the object. Now what we have is the first referent is the object and patient. So even though it's first in terms of prominence, it's the first mention, it's not prominent in terms of grammatical role or theta role. And referent to is prominent in terms of subjecthood and agenthood, but it's the last mention. If we make it further complicated, and instead of using active accusative verbs, if we use dative experiential verb, such as aufgefallen, so notice, the spectator has noticed the terrorist. So in this case, what we have is the first referent has object and agent features, whereas referent to is the subject, and it's the patient, and it's the last mention as well. Of course, the second referent. And we can do the same word order variation, and we can get another distribution, where referent 1 has is subject and patient, and referent 2 is object and agent. Okay, so this is kind of a design of a 2x2 design, where we have 2 different kinds of verbs and 2 different word orders, and we get a varied distribution of prominence-lending cues. So the data that I'm going to consider, which is Schumacher data 2016, it's an antecedent selection task. So they carried out an antecedent selection task using the same design. So they had these 4 conditions, and they had 2 different pronouns. So either a personal pronoun or a demonstrative pronoun. And they asked participants to resolve the pronoun. So what does the pronoun refer to? Okay. And this is the data for condition active accusative verb in canonical word order. So what you see in the bar plot is the frequency or percentages of selecting referent to 1 versus referent 2, and that's for personal pronoun. Okay, so clearly there is an effect of prominence. So subject, first mention, and agent is selected more often, around 62% of the times. And now this is data for the other 3 conditions. Okay, and now we have data, and this the data for the demonstrative pronouns, again across 4 conditions. So what they found is that, so there were 3 interesting effects that they found across these 4 conditions. So for personal pronouns, they found that for active accusative verbs, no matter what the word order is, the antecedent that is preferred for personal pronoun is the subject and agent. Okay, so independent of the word order, they prefer the subject and the agent. And for demonstrative pronouns, so it's just a preference. It's still like they can refer to the other reference, but just there is a stronger preference. Whereas the preference for the demonstrative pronoun is in the other direction. This is what we would have expected. The interesting case is with the dative experiencer verb in canonical word order. So what they found is that personal pronouns prefer the first mentioned referent, which is object, which has object grammatical role, but it's the agent. Whereas demonstrative pronouns prefer the last mentioned antecedent, which has subject and patient role. Okay. And the third effect that they reported is there was no preference when it was non-canonical word order in dative experiencer verbs. Okay, for both demonstrative pronouns and personal pronouns. All right, so this is the data we have, and so our goal was to use the Q-based retrieval model and try to see how we can use Q-based retrieval model, or can we use the Q-based retrieval model to capture this difference between personal and demonstrative pronouns. Okay, so why Q-based retrieval model? So all these reasons, and also because I like it, but there are also strong reasons that it has been used for many linguistic dependencies. Okay, it has been very influential for explaining retrieval processes in various linguistic dependencies. And it has also provoked many experimental studies. So if you see experimental work done in last 10, 12 years, there is a lot of influence from Q-based retrieval theory. And I think it's a good model for explaining the differences between personal and demonstrative pronoun. Okay, and it has also been used for pronoun antecedent dependency. So for English reflexive pronouns and also for German possessive pronouns. So our modeling assumptions are the following. So the task is the same. It's an offline task of antecedent selection. And the model, so we model the online processing of the sentence. And what we assume is that the preferred antecedent is an antecedent that is retrieved at the onset of the pronoun. So when the model is processing the pronoun, the antecedent that it tries to retrieve is the one that will be preferred. Okay, that's one. So, and how do we say that the model captures an effect? So we are making a simpler assumption here. If the model prefers across all simulations, if it prefers, so it prefers more than 50% of the trials, one antecedent, then that would be the antecedent that is preferred in general. So it's not the exact percentages that we are trying to model, but just the preference in terms of, say, is it about chance or not? And then we select the model that captures most of the effects in the data. So as a modeling procedure, what we did is that, so we started with a model for personal pronouns. So these three effects that I mentioned, we tried to model them across for personal pronoun. And we started with a vanilla Q-based retrieval model that has been used in the past, okay? So, and then we are trying to improve the model till we get like, a best model for personal pronouns. And then the idea is that since demonstrative pronouns and personal pronouns have these complementary preferences, if we just have complementary retrieval cues, that should also capture the data for the demonstrative pronoun. So take the best model for personal pronouns and just change the cues. So don't try to make too many changes in the model, but make only minimal changes, which are driven by what we know about or what we think about personal pronouns and demonstrative pronouns, their differences. All right, so these are the predictions for the baseline model, which retrieves the antecedent based on cues such as gender, number, and the category. And the predictions of the models are really not very exciting. It does not capture any of the effects. So basically, it predicts that referent 2 is the preferred one across all 4 conditions. So it's definitely not a great model. So the next model, as an improvement over the previous one, what we did is that we added prominence cues. So cues such as thematic role, grammatical role, and order of mention. Okay. And see if the model performs better. So indeed, it captured effects which are, so first 2 effects, so effect 1 and effect 2, which is, so personal pronoun prefers the subject antecedent in active accusative verbs, and it preferred the first mentioned object agent in the dative experience verb in canonical word order. So it captures 2 out of 3 effects. But still, it does not capture the last effect, and it predicts that referent 1 is preferred, whereas we should expect that there is no preference. Now, from the data, Schumacher et al. Suggested that even though all the prominence factors are interacting, thematic role has a higher weightage. It's more important than other factors as far as personal pronouns and demonstrative pronouns are concerned. So to incorporate their proposal into a model, we tried to extend the existing Q-based retrieval model. So in the existing Q-based retrieval model, all retrieval queues are the same. So there is no difference between any retrieval queue. Okay, so we wanted to have this extra importance for the thematic role queue. So we made changes in the way the activation spreads from a retrieval queue to to different reference, and we added a weight parameter for each queue. So weight parameter specifies the amount of activation that will spread to the reference, and if if a certain queue is more important, it spreads more activation. Okay, and we assume that so we actually fit this value for personal pronouns. So we assign weight of 1.5 times higher than other queues. So thematic role is weighted higher. All other queues are equal. So everything else is same as the previous model, just that we added one extra parameter. And it indeed performs better than the previous two models. Okay, so now we are able to capture also the effect of effect 3 for dative experiencer verbs in non-canonical word order. All right, now we use the same model that we use for, so model 3 that we use for personal pronouns, and now we just give the complementary values for the prominence queue. So instead of agent, it's patient, and the grammatical role is object, and the order of mention is the last mention. Okay, and now our idea is that since these two pronouns have this complementary distribution in terms of antecedent, they should also explain the data for demonstrative pronouns. It does capture effect 1 and 2, but for the last, so effect 3 is not really captured. So data shows no preference between the two reference, but our model showed a preference for reference 2. Now we can go on and make more modifications in the model, but one conclusion that we draw from this part is that maybe these two personal pronouns and demonstrative pronouns, they are not exactly complementary. There is still more difference than just being complementary. So we don't have a modified model for demonstrative pronoun yet, but I think we are happy so far that it at least captures 2 out of the 3 effects for demonstrative pronouns. Okay, so just to summarize, what we have shown is that we have shown an extension of queue-based retrieval model in terms of prominence queues. And we have also shown an extension where a prominence queues can be weighted to capture certain variance in the antecedent preferences for personal pronouns, and to a certain extent also for demonstrative pronouns. And what are the implications for the modeling? So it's not just about this particular data, but in general, what implication do we have because of this modeling experiment? So one is that when we run some experiments and we find that, oh, one factor is more important than the other, what we conclude is that, oh, factor X is more important than factor Y. So what we are trying to do is we are trying to quantify how much more important. Here we use 1.5 as the number. That may not be the universal truth for thematic role, but still we are trying to have an actual number for this kind of statement. So we are trying to quantify this statement. And of course, we have extension for queue-based retrieval model in terms of prominence queues and weighted retrieval queues. And then there is, so one queue that we are using, which is the positional queue, and I'm not fully comfortable with that, but I think it's a placeholder for a better model at the moment. All right, so thanks to DFG and the Prominence in Language project for their generous funding, and thanks a lot for your attention. Look forward to your questions.
Hello, this is very interesting. I'm familiar with the model of Q retrieval and all the whole theoretical assumptions about working memory that go behind it, and yeah, like a cognitive processing model. So I appreciate the theoretical impact of that. But perhaps because I'm not a modeler myself, so maybe you can clarify for people who don't do modeling, or yeah, I don't. How is this different from just writing a set of rules that are ordered? Right, because you told us what the rules are, right? You have these cues, the pronoun is going to match with the agent, which is subject, etc. The demonstrative is going to match with the object, that is second mention, etc. So you already know the rules. So how is it different from just specifying a set of rules that are ordered in their application? So first do this, and if it doesn't work, do next, or what? See what I mean? Like a context-free grammar or some other kind of model. What do we gain by this modeling that we wouldn't guess from just having a description of what counts at the point of interpreting the pronoun? See what I mean?
Yeah.
I mean, I appreciate that there's a theoretical explanation behind this, which has to do with working memory and how Q retrieval works. So I appreciate that that is a contribution in itself. But let's say for the rest of us that don't know much about modeling, what is the insight here that we should get at? See what I'm saying?
Right. So one is what I mentioned in the previous slide, which is so instead of saying that factor A is more important than factor B, we're actually trying to put a number on that. Okay,
but what is it? Yeah, but then what does it mean to put a number on this? You mean you make it mathematically accurate? Is that what you mean?
Exactly. So now we can use the same number. If the number was true, say 1.5, if the number was true, now we can use this to generate new predictions and then go on and test it, which won't be possible with, say, just a descriptive model, right? And here it turns out that what we expected in for the model to do, that turned out to be the case in some cases, okay? It still did not turn out the same to be for the demonstrative pronouns. So this was still surprising. So this is something we learned by actually modeling it.
Okay.
So if we had not done that, we would not have come to this conclusion.
Yeah.
Or we would not have come to the conclusion that we have to put certain weight for certain parameter and the weight has to be blah, blah, blah. So that's one more thing. And also in terms of modeling, it's like, so the vanilla Q-based retrieval model for retrieving an antecedent is it's not sufficient. We need to have something else, right?
Okay. Okay, well, thank you. That was very
useful. Thanks.
Hi, yeah, thanks a lot. So Jakub Dotlačil, Utrecht University. I had two questions, so I'll try both of them. The first one was, did you actually look at more like quantitative predictions of the model? So you capture the qualitative pattern quite well, but did you look at like exactly the parameter values and how good you could get the quantitative fit? And that might also be the answer to the previous question, because if you just assume these features or these cues are relevant, then of course you get already the qualitative pattern, but one advantage of doing cognitive modeling is that you could get actually very precise quantitative predictions, and you could, for example, make also predictions for reading times for another study. So did you look at any of that?
Right. So I did not look at those precise numbers yet. So it's right now only like, is there preference for 1/2? Okay. And why is that? Because I was, so there's only one data set that I'm trying to model, but this is not just the one data set. We have data for demonstrative pronouns and personal pronouns in German across different data sets. So I would really like to, so instead of having just a quantitative prediction for like, something like say 72% versus 26%, whatever, instead of having just exactly that number for just this data set, I think it's important that we start at like, at least there is a preference or not. And maybe these numbers are not like, they are just for this data set. So this is based on 32 participants and say 36 sentences. They might vary. So that's one answer. Second is I'm trying to, so the next step is I'm going to try to have parameters for at the individual level as well. But right now, unfortunately, we don't have the data. I only have the means. So, but yeah, that's the idea. We are planning to do that. Yes. Thanks.
Can I ask the other question?
Yeah.
So I was wondering whether you looked at cognitive models that also try to explain pronoun resolution. So in particular, what was done in University of Groningen around the group of Petra Hendricks and Jacqueline van Rij. So they actually tried to explain preferences for pronoun, but they used a bit different idea behind. So they actually thought that there's some kind of competition. So you have say personal pronoun as the the default, and then the demonstrative it shows a different preference because basically you have competition between the personal pronoun and the other form. And they try to implement that in a cognitive model. So I was wondering whether you have any thoughts about like why not to go that way?
Yeah, that's a good suggestion. I haven't done that, but yeah, that's I would like to do that. And at some point, once we have like relatively decent model, then it would be interesting to compare these two models. And then it's not just about what numbers it predicts, but how they are predicting that, and then comparing between these two models, which one is like and then of course we have to test why they are predicting this, and does that make sense based on like running a follow-up experiment.
Yeah, exactly.
So we could have predictions for like once we have the model, we could have prediction that can be tested for both the models. So I'm sure that we can have prediction for this particular model, and then we can go on and test them. And after we do that, we can like evaluate between these two models. But I agree it should be done, and I'm considering. Yeah,
thanks.
Thanks for the talk. One very probably dumb methodological question: is this leave one out cross-validation? Is there some generalization to where you try to predict unobserved data, or you fit and then show results on the same data?
So I fit the data for personal pronouns.
Yeah.
So we looked at the data, we tried to fit it, and how far can we go if we try to fit it? Just this data set.
So you haven't tried to make predictions for like held out some observations and tried to see whether you can.
Yeah, we did that for demonstrative pronouns. So we did not make any changes for the demonstrative pronouns model other than just changing the retrieval cues. And so, yeah.
Okay. And the other question, to what extent do you think this same model could work for English or for another language?
Sorry, say it again, I didn't get that.
To what extent do you think a model with this extra pieces of information could work for other languages? Are we bound to like modify the model with extra features for different languages? Or is it just that these features are non-informative in certain languages, and so if you give it data, then it would figure out, okay, this matters for this, it doesn't matter for that.
Right. Yeah, that's a really good question. So my idea is that, so right now we have come up with just these set of retrieval cues, and these are limited to like, so they are based on one data set for German. But the idea is that if we take data sets for pronouns across different languages, what are the changes that we need to make, what retrieval cues probably we need to add, and what, say, weights we need to adjust. Of course, it's going to be different for different languages because the pronoun preferences still change across languages. Even in closely related languages, they change. So yeah, that's the idea, is that to start with one data set for German and then build it up to more data sets in German, and then like make it more generic, so that, so basically have something like an architecture where you have a set of say retrieval cues or whichever like modeling features we use, and how do they change between languages. So that's the idea. Yeah, thanks.
Thank you.
Do we have time for another? Hi, thanks. That was very interesting. Jennifer Arnold, UNC Chapel Hill. And so he was asking about kind of a scale-up question, like how this could scale up to other languages. And I was wondering whether this would easily scale up to other kinds of phenomena that are known to affect pronoun comprehension. I mean, so there's a bunch of other things you could look at. There's social effects like gazing and pointing. coherence relations like Elsie mentioned after our talk, and other things that come from the discourse text. But in particular, I was wondering whether it might be hard for this model to account for things that come after the pronoun. So an example from English might be, Anna gave Liz a gift and she said, happy birthday. Or Anna gave Liz a gift and she said, thank you. And so depending on what is said afterwards, that's going to change how you interpret that pronoun. And could this be scaled up to account for post-pronominal effects?
Right. So in this case, there would be some kind of reanalysis based on what follows after the pronoun, because depending on what follows after the pronoun, the resolution changes. So that's not the idea to model that part. So the idea of this model is that as soon as at the onset of the pronoun, what are the processes that take place? There will be some reanalysis afterwards, but what are the
so you're
processes
only
that
looking
will
at
definitely
initial.
take place at the pronoun?
Okay, what about adaptation like we showed?
Well, so for that, I think you have to assume that there is changes in these weights or which cues you are using. So then you will just, basically, so I would assume that as humans, we are making changes in these preferences. Yeah.
Okay, thank you.
Thank you.
Okay, let's thank Umesh one last time. Thank you.
Thank you.